Hello to everyone. My name is Vitaly Ishchenko. I am from Vinnytsia National Technical University from Ukraine, and I would like to present the presentation. The topic is environmental pollution from nuclear power plants, modeling for the Khmelnytskyi nuclear power plant in Ukraine. Reliable electricity sources are necessary in modern world. It is needed to maintain critical infrastructure. Today, heat power plants generate most of electricity in many countries. Despite many efforts intended to improve their operation, because their efficiency has both economic and ecological effect, there are still many environmental issues. Under this circumstance, nuclear power becomes the priority electricity source for many countries. However, nuclear power plants also emit environmental pollution like any other industry. There are gases, liquid, and solid emissions from the nuclear power plants. And obviously, such emissions include radioactive elements. According to the energy strategies of many countries, construction of more nuclear power plants is planned. In Ukraine, more nuclear units at existing nuclear power plants are projected with a total capacity of up to 22 gigawatts. Similar strategies are accepted in USA, China, India, and many other countries. National safety, including reliable energy supply, is always of the highest priority, but environmental risks should not be underestimated. There are many studies revealing radionuclides emission from nuclear power plants. Radionuclides can be disseminated and precipitated at large areas, leading to soil and crop pollution. The modeling of radionuclide emission for the Fukushima nuclear power plant in Japan was done by many authors, and they have found 22% of cesium and 13% of iodine distributed over 500,000 square kilometers area after the Fukushima accident. And other studies also reported about long distances of radionuclides dissemination from nuclear power plants. And besides, impact on humans and environmental issues resulting from air emissions of nuclear power plants are analyzed in other studies. Also, there is a research dedicated to the nuclear power contribution to climate protection due to decreased gases emissions in comparison to energy production from fossil fuels. This research analyzes radionuclide dissemination from nuclear power plant for the case study of Khmelnytskyi nuclear power plant in Ukraine, and the objectives of this study are as follows. First, assessment of radionuclides and non-radioactive chemicals concentration in the air near Khmelnytskyi nuclear power plant. And second, modeling of agricultural products contamination during the maximal projected accident at Khmelnytskyi nuclear power plant. For this purpose, the following materials and methods were used. Radionuclides emission from Khmelnytskyi nuclear power plant was measured in the laboratory of the Department of Environmental Protection at the power plant, Khmelnytskyi power plant. Air pollution at the area of the power plant was analyzed using high-altitude radio sensing of the atmosphere. Air emissions from the turbine condenser ejectors was registered at Shepetivka Research Station, some 25 kilometers from Khmelnytskyi nuclear power plant. The concentration of radionuclides was measured by radiometers combined in automatic system of radiological control. The results used in this paper are average for 2014-2016 years. Besides contamination of agricultural products with aerosol radionuclides for a maximal projected accident at Khmelnytskyi nuclear power plant was calculated based upon radionuclides emission and sedimentation. For this purpose, the following equations were used. First, radionuclides concentrations in agricultural products were calculated according to this equation, and you can see below what is these characteristics. And below you also can find another equations which were used to calculate the pollution of agricultural products. You can see it on the screen. Also, below is some input data to calculate radionuclide concentration in atmosphere and soil contamination with radionuclide according to the known methodology. And this methodology is based on the Gaussian air pollutant dispersion and sedimentation equations. So here is the input data for this calculation. Next, go to the results which were obtained. First of all, let's talk about sources of radionuclides emission from Khmelnytskyi nuclear power plant. For a typical nuclear power plant, radionuclides can be found in products of nuclear fuel decomposition, activation products, and products of constructions corrosion. Even if a nuclear power plant operates as usual, some fission products can be transferred into the heat carrier if damage of the fuel element coverage happens. And one of the main fission products in the heat carrier in the primary circuit in Khmelnytskyi power plant is tritium. It has around 12 years half-life. It is a radioactive isotope of hydrogen. A tritium generated in the reactor of a nuclear power plant as a result of the following processes. First, radioactive decay of nuclear fuel. Second, combination of the neutron and deuterium nuclei. And third, interactions of the fast neutrons and reactor constructions. And fourth, boric acid activation in the heat carrier of the primary circuit. Below you can see some sources of gases emissions from the primary circuit at Khmelnytskyi power plant. This includes aerosols, tritium water vapor, some noble gases, and many other gases. And also here is presented sources of radioactive aerosols emission at the Khmelnytskyi nuclear power plants, and these include two main sources: ventilation tubes of the reactor and also turbine ejector. In this table, you can see the data on radionuclides emission from the ventilation tubes of Khmelnytskyi nuclear power plant. This is average data in the years 2010, 2015. 2015, yes. So these are the results. And suspended aerosol particles may also emit into the air during transferring the ash and dust. The concentration depends on the surface and meteorological parameters. The highest concentrations of suspended particles in the air near the Khmelnytskyi power plant were measured in the range from 3 to 7 milligrams per cubic meter. It is in the Nitition 4 kilometers from the plant, and it's a one research station, and a bit lower at 1.65 milligrams per cubic meter in another research station, some 5 kilometers to the east from the plant. Next results include the maximum concentrations of some non-radioactive chemicals measured in the air near the Khmelnytskyi nuclear power plant. There are some also non-radioactive emissions generating harmful gases during technological process. And at the Khmelnytskyi nuclear power plant, up to 90% of non-radioactive air emissions are generated in the boiler room. Emissions from other sources are low due to the low capacity of gas treatment equipment. So, at the Khmelnytskyi nuclear power plant, the monitoring of meteorological and aerial characteristics of the atmosphere is carried out in order to assess the impact of air emissions. And these parameters directly influence the radionuclides transportation. And another result, it is the assessment of crop contamination with aerosol radionuclides from nuclear power plant. The level of radioactive contamination of agricultural crop and its influence on elements of food chain, including animals and humans, are determined by the following. Total amount of the radionuclides released into the environment, then the nature of these radionuclides dissemination, then physicochemical properties of radionuclides, and also properties of contaminated soil and plants. The main contribution to the gas aerosol emission of Khmelnytskyi nuclear power plant is made by inert radioactive gases, which do not directly migrate in the ecosystem along food chain presented in this picture, and the expected contribution of iodine radioisotopes and activated corrosion products to the total emission is very small. Many of these radionuclides have several hours half-life, and when considering the radionuclides migration in the ecosystems, a primary attention should be given to radioisotopes of so-called biogenic chemical elements, and to assess the consequences of impact. The estimation of possible values of the territory contamination with radionuclides should be one of the main criteria, along with data on soil and climatic conditions of the territory, features of agricultural manufacturing, and so on. So let's look at the results of modeling according to the methods used, methods described before. Let's look at the maximum contamination of agricultural products with aerosol radionuclides when modeling maximum accident at the Khmelnytskyi nuclear power plants. These results presented in becquerels per kilogram in each agricultural product. You see bread, milk, meat, vegetables, and fruits, and different results for strontium, cesium, and iodine at different distances from Khmelnytskyi nuclear power plant, from 2 kilometers to 25 kilometers away from the station. And you can see from the table that main attention should be given to iodine nuclide. The highest concentrations of selected radionuclides in agricultural products are found in vegetables and meat. The contamination level is significantly lower than the estimates given above if urgent measures are done in time. And finally, our conclusions to this study. Nuclear power plants generate air emissions from the basic and supplementary equipment. Air emissions may contain radionuclides and non-radioactive aerosols, causing environmental risks and harmful effects on the human. Majority of the sources of air emission operate periodically. Therefore, the total emission is relatively small. The chemicals concentration in the air near the Khmelnytskyi nuclear power plant are found to be below the Ukrainian limits. Only nitrogen dioxide concentration is found to slightly exceed the limit. The highest concentrations are measured for argon, nitrogen, xenon, tritium, and krypton radionuclides. In case of a project accident, the concentrations of radionuclides in different agricultural products are found to be very high, even at the distance of 20 kilometers and more from power plant. Therefore, people living at the territories where pollution from nuclear power plants may occur have to know the rules of behavior in emergency situations. Despite the low level of air pollution during usual exploitation, the environmental risks of nuclear power plant operation have to be thoroughly assessed. The results obtained may be used when assessing environmental performance of nuclear power plants. Besides, the data on pollution of agricultural products with radionuclides is crucial for providing environmental safety. Thank you for your attention. The presentation is finishing. Thank you.